today's lesson, we're still doing direct and inverse, but now we're talking about direct and inverse with powers. And then the second part of today, so we're talking about direct and inverse that are combined, that may both exist in the same equation, okay? Everything we've done up to this point has two letters in it, an X and a Y, or if it's different letters, it might be pay and hours. So we've only really related two things. But if you know some of the formulas that you're familiar with, probably from science class or even from other math classes, it's possible to have two or three different letters in it. Does that make sense? So we're going to talk about what happens if that occurs. All right, first of all, direct and inverse relationships and powers. Notice that this formula is A is equal to pi times r squared. Does anybody know what this is the equation for?
Diameter.
No, it's not the diameter, and no, it's not 3.14. What's the equation A equals pi r squared for? Area of a circle. So what we know is, because A is on top and R is on top, what that means is as the radius gets bigger, the area gets bigger, right? But when you add a power, it changes how much it affects it. So let's just examine it. What if I said, let's let this be a radius of 1 unit. I would have so much area contained in the circle. Could I calculate the area of that circle? Okay, it's going to be pi times the radius of 1 squared. Now, what's 1 squared? 1 times 1? 1. And we're going to leave pi in the answer. So the area of a circle with radius 1 is 1 pi units squared. Everybody good? Okay, we won't, yes, that might not be a bad idea to draw that on your paper. We won't necessarily multiply times 3.14. So as you move forward into the math classes, they're going to start leaving pi in the answers, because pi is a more exact answer. When you multiply times 3.14, that's actually an approximated answer because you're chopping off a bunch of decimals. Okay, let's talk about what happens if we increase it to double the radius. In other words, I'm going to make the radius twice as long as before. So now the radius is length 2 units. What happened to the area? All right, as the radius got larger, guess what happens to the area? It got larger too, right? But how much larger? Okay, let's calculate it. Pi times radius of 2 squared. Now, order of operations tell me I need to take 2 and square it. 2 squared is 4. So what happens is the area is 4 times pi. Let's take a look at our answers. My radius doubled, right? My radius went from 1 to 2. It went up twice as big, right? But how did the area change? It went up not just once or twice as bigger, but 3, 4 times bigger. Does everybody understand? So what happens is when you have powers, it's still direct. But it means as one increases, the other is going to increase at a much faster rate. Does that make sense? It's still direct. Okay? But it's going to happen much, much faster. As one goes up, the other ones go up faster than you expect because of the square. Okay, what if I, just for sake of arguing or just for sake of making a point, what if I made the radius 3 times longer? So it'd be area would be pi times radius square, which is 3 squared, which is 9. So when you triple the radius, the area gets 9 times bigger. So as one went up, the other one went up, it just went up a lot more or a lot faster. Does everybody understand that? So pay attention. When you see r to the second power, how do you think they're going to write that? How do you think we're going to say that? We say r squared. Okay? Everybody understand? So today, I want you to be aware that it can still be direct, it can still vary directly, but sometimes we can have powers and it still be a direct relationship. It just won't be linear anymore. Okay, I want to talk about side, volume equals side cubed. So when you see to the third power, what do we say? Cubed. Okay, raised to the third power or cube. So those are the two that you're going to see. you're really not probably going to see raised to the fourth power, raised to the fifth power. They're going to do some squares. They're going to do some cubes. So be on the lookout for those. Don't let those pass you by. Volume is side cubed. I want you to imagine a small, like dice, right? What if it was side 1 unit? 1 unit back, 1 unit on the side, 1 unit high. What is the volume of a box, or like a dice? Y'all can visualize a dice, can't you? It's 1 unit on each dimension. What would it be? 1 to the third power. Volume is what? 1. Everybody good? All right. Now, what happens if I increase the side to one that's twice as big? Okay, so now the side is length 2. Volume is how much space it's going to take up inside the box, or how much stuff I could use to fill up the box, right? So I am going to double the dimensions, but I'm doubling it in the front, in the depth, and in the height. Do you understand? I'm doubling it in 3 different directions. What is the volume of my new box? So that's 2 cubed. It's 2 times 2 is 4, times 2 again is 8. So as my side went twice as big, what happened to my volume? It went from 1 to 8. It went what? 8 times bigger. So it still is direct, right? One goes up, the other goes up. Or if one went down, the other one would go down. It's just going to increase or decrease at a much faster rate. Is everybody okay? Are we good? Okay. I want to talk a little bit about an inverse relationship. This actually works. The force, okay, and I'm trying to relate just to distance. The attractive force between any two things, whether it's gravitational force or magnetic force, can be calculated just like this. There's a much more complicated equation, but this is how it works. Okay, I taught physics for many, many years, so I'm pretty familiar with it, but here's how I want you to think of it. Force is inversely proportional to distance squared. Think about 2 magnets, right? Let's say we have them 2 units apart. You with me? Okay. When they're 2 units apart, or a distance of 2, they have somewhat of an attractive force. Let's say one's a north magnet, one's a south magnet. Okay? Or if you had charges, one's a positive charge, one's a negative charge, right? They are attracted. You ever remember that? Y'all have had that in science, right? North and south. Opposites attract, likes repel. So, let's say a distance of 2. What happens if we decrease the distance between them? Okay? So I'm going to, well, let's just do it the other way. It might be easier. I'm going to say constant. I'm just going to say the constant's 1. Let's make it easy. Let the constant be 1. Let's go from 2 squared, cut it in half, and go to 1 squared. Okay? What's 1 over 2 squared? What's 1 over 2 squared? It's what? 1/4. The force is 1/4 of a Newton. Oh, okay. It could be the attractive force between 2 people in a room, you know. Actually I had that in one of my physics problem once. The force of attraction between 2 people across the room could be calculated with the attractive force of a magnet. You spy each other across the room, and as you get closer, the attraction does what? Do you think it grows or gets weaker? It probably grows. Have you ever noticed that if you scooted 2 magnets together, they don't do anything? And you scoot them a little close together, they don't do anything. You scoot them a little closer together, but you don't let them touch, what will they do on their own? They'll snap together, won't they? You ever played with magnets? Or you have, haven't you? I used to have a set of those sizzlers. Y'all ever played those sizzlers? You know what I'm talking about? They look like 2 big old magnets, and you throw them up together, and you rotate them, and they sizzle. Anyway, I don't know. We go from 1/4 of a Newton to what's 1 over 1 squared? 1 Newton. We got 4 times more by coming what? So if you and your significant other, okay, let's say my significant other is standing on the other side of this carpet. Oh gosh, she's so good looking. My husband's sitting over here across the carpet from me. Now if I increase the distance, Now I'm 4 times stronger attracted to him because he's on right there.
No,
Does that make sense?
it'd be like 4 times less because 1/4 is like 1.
Okay, 1/4 is not even one whole unit of force, right?
Yeah, so
So then it goes to a unit of 1. From 1/4 to 1 increases 4 times more.
yeah,
Okay?
yeah.
All right. I'm going to move on.
Voltage equals.
Okay. This is Ohm's law. I did forget to finish my fractions, so I need you to grab your pencils and write these in. A is equal to F over M. And F is equal to M divided by D squared. Yeah. Yeah. Okay. This is Ohm's law. This talks about the current, voltage, and resistance in a circuit. You guys had a little bit of electricity? Did y'all ever get to hook up Christmas lights or do any kind of cool things like that?
Yeah.
Okay. Here's what you need to know. Voltage is your power source that puts out the electrical energy, right? Whether it comes from a plug-in or whether it comes from a battery, every battery has a V on it. If you've ever noticed, it says for voltage, right? Does anybody know how much it comes out of our outlets? 110 volts. So that provides the push that forces the current to move through the circuit. How fast the current moves through the circuit is the current, okay? And then the resistance is anything that's in the circuit that slows it down. So if I put a light bulb in it, the electricity has to run through the light bulb. So if I only have a couple of light bulbs, it's not too bad. The circuit, the current can still run pretty good through it. Let's say I add a bunch of light bulbs. Let's say I add 10. Now it's going to slow down the overall speed of the circuit, and they're all going to get a little dimmer. Does that make sense? Okay. This describes Ohm's law. How many letters do you see?
3.
So this is now what we call combined or joint variation. This one is actually jointly related. Write that down on your paper. All right. Jointly related is another word that always means directly related. If it's inverse, they have to specifically say inversely related. So if they don't use the word inverse, you assume it's always direct. It's kind of like a default setting. Most of you, when you went and got a new phone, what was the default language that probably came up on your phone in America? English. You can change it to other languages, but the default language was probably English. Okay, so that's like your basic setting. You can change it. So if it doesn't specifically tell me inverse, I'm going to always assume that it's directly. So what that means is if I had the R, right, I is on top and what? V is on top. So voltage is directly related to I, which is current. I don't know why current has a letter I, but it does. Okay? Now, let me hide the I. Okay? What about the R and the V? The resistance is also directly related to the what? Voltage. Both of them at the same time. So if I wanted to write this statement, and you are going to write this statement, voltage is, anytime you see an equals, most of the time you can say is, or you can say varies. Directly related, okay? Or sometimes in the writing they will say jointly related to I current and, it's the first time we've ever used the word and in any of these sentences, and resistance. Okay, so voltage, notice I've used every word. Voltage, okay, it's directly related to current and resistance. Okay, so if it says the word directly, everything's on top of a fraction. Is that good? All right, we've talked about this one before. A, F, and M, does anybody know what that is?
Acceleration.
Acceleration is how fast it speeds up. Force is how much you push or pull on it. And the mass is how much actual matter is contained in the body or the object. So, now I want you to imagine hiding M. Don't look at M. Just look at A and F. How are those two related? A is up when F is up, right? So I'm going to say acceleration, write this down, is, now I'm not mentioning M right now, I'm just talking about F. I'm only focusing on one at a time. So it's what? Directly related to what? F, force, then what? And now I'm going to hide the F, and I want you to talk to me about A and M. A is where? Up, and M is down. So after my and statement, and what? And is inversely proportional to, so we had one equation that had both types of variation contained in them. Okay, as a quick rule, as a quick observation, if it's on top, and this is on top, so if it's on top, it's what? Directly related. Is that good? What happens if I see part of it on the denominator or in the bottom? That is inversely related. So it is okay to have a top and a bottom, and you would use the word and in any statement. Okay? All right. Try one on your own. I want to see how you handle this. And when you get to the D, is it just inversely or directly related to D? To the square of D, or D squared. Make sure you mention the square in your statement. You write a statement for 3 right now. So the idea is to write a sentence for force is and see if you can do it. So you can pause the video, write it, and see if you get it. All right. So everybody seems to be feeling okay with the idea that you can have both kinds of variation occur at the same time. Okay. We're going to look at the other side. I'm only going to do 1 or 2 with you, and I'm going to turn you loose. You'll have this done in about 4 minutes. And then we'll start actually solving with some powers. Okay, this is on the joint and combined variation side, so everybody's looking at the right-hand page of their sheet. Number 1, they're giving you all words. V varies. Guess what it starts with? V. What do you write down for varies? Equals. Jointly. Means directly. So it says B and H. BH. Now it also says in your directions not to forget constant K. So we're going to use a little constant K. So every time you're going to squeeze little constant K in the front. Okay, constant K always goes either in the front or on top. So constant K in front, or if you have a choice, it goes on top. That's too easy, isn't it? Number 2, T varies directly as W and inversely as N. T equals. Okay, now I see directly and inversely, so guess what I need to have in my equation? I need to have it to bar. Okay, W, so it says directly as W. So when it says directly, I know it goes on top. And then when it says what? Inversely, it goes on the bottom. Okay, I have to put constant K. Where does constant K go? In front, on top. It always defaults to the top. If there's ever a question, it defaults to the top. So it's in front, it's also on top. Are you good now? So you are working right now on your own 3 through 12.